When I'm giving percent, it means that everything should pull up to 100%. Is it not? When carbon itself is 90, oxygen will be 3%. Correct? And the rest will be the composition. So, I'll get back to a small revision. There is a formula called Dulong's formula for calculation of theoretical amount of calorific value. Okay, the Dulong's formula is given by HCV, high calorific value or gross calorific value, is equal to, I'm finding percentage there, 1 by 100 into 8080 carbon plus 34,500 into H, capital H minus O by 8, where this total term capital H minus O by 8 is the available hydrogen, where capital H is the total amount of hydrogen that is present in the fuel. O by 8 is the fixed or combined hydrogen. I told you, the fuels, oxygen is never available in free. It is always present in the combined state with hydrogen as moisture, which actually decreases the calorific value of the fuel. Okay. So how much amount of combined hydrogen will be there? O by 8 amount of combined hydrogen or fixed hydrogen will be there. Capital H is the total amount of hydrogen, and H minus O by 8 is the available hydrogen, which gives the calorific value to the fuel. And 34,500 into H minus O by 8 plus 2240 into sulfur. Okay, kilocalories per kg are the units. Okay, this is about, is the board clear to all of you? And there's another formula. HCV is equal to LCV plus 9 capital H by 100 into 587 kilocalories per kg. Where again here capital H is the total amount of hydrogen. 9 indicates how much amount of moisture is formed per unit mass of hydrogen. Percentage 100. 587 is the rated heat of condensation of steam. Okay, and is the discussion. Okay, so in yesterday's numerical, they gave LCV and they asked us to find the percentage of hydrogen. Okay, now if you take carbon as 90%, oxygen as 3%, not 30%, obviously. It is 3%. You will not get a negative answer. Sulfur is 0.5%. Nitrogen is 0.5%. Ash is 2.5%. Okay, rest all are the unwanted products in the combustion. Okay, now you will get a meaningful answer. Check. Okay, it's already 2:10. I want to start giving you all the numericals. This or yesterday's format question is a one question on the calorific value, and today what numericals we are doing regarding the air quantities. Okay, that one is also very important. Either this or air quantities is a compulsory question in your mid and final exams. What they will do is they'll give one numerical and they'll give a theory question to it as part A and B. for essay or 2 marks question. 2 marks question generally these are not included, less included. Okay. Now shall I start the discussion? Check the answer. Okay. So before I tell you about the start discussing about today's numericals, I'll have to do a small revision. నిన్న ఏం చెప్పాను? Combustion ante it's an exothermic oxidation reaction. Okay, and oxygen actually burns the carbon and hydrogen that is present in the fuel. It's a thumb rule that any material acting as a fuel will contain carbon and hydrogen as one of the main components in it. Okay, and whenever I'm saying it is giving lot of heat energy, it means oxidation of carbon, hydrogen along with other elements is taking place. While discussing the calorific value of fuels, we have concluded that every fuel has carbon, hydrogen, nitrogen, sulfur and oxygen present in it. Most of the fuels, I'd say. Okay, and they undergo oxidation forming corresponding oxides, and they give a lot of heat energy, which is calculated as the calorific value. Now, calorific value is calculated in two ways: high or gross calorific value, low or net calorific value. Units are kilocals per kg, metric units are calories per gram, CGS units, or British thermal unit. Okay, that is British thermal unit per degrees Fahrenheit are the expressions for expressing the calorific value units. Okay, when gaseous fuels are burnt, the calorific value is expressed as kilocals per meter cube. Okay, or kilocals per centimeter cube are the units. And I also told you all that the interconversion formula of various units of heat or calorific value are 1000 calories is equal to 1 kilocal is equal to 3.96 British thermal units is equal to 2.2 centigrade heat unit. These are the formulae which has to be memorized to solve the numericals on the calorific value. And then I told you calorific value is measured experimentally using calorimeter and theoretically using Dulong's formula. That's what formula you're seeing on the board is the Dulong's formula. And we have yesterday solved one or two numericals on this formula. Okay, and hence is my discussion. Then we moved on yesterday calculating the air quantities that are required for complete combustion of fuel. What will happen if the fuel does not undergo complete combustion? Obviously, the straightforward answer is its calorific value comes down. Is it not? So I should ensure that the fuel should be supplied with lot of oxygen or required oxygen for complete oxidation. Okay. But then we know that air does not contain only oxygen. It contains various other gases. So the amount of oxygen that is present in air is 23% by weight and 21% by volume. Okay, means you're calculating the amount of oxygen by weight, it is 23%, and by volume it is 21%. Okay, and hence is the discussion. Then we have written the 10 rules that are useful, 7 or 8 rules that are useful for calculating the air quantities. Okay, we spoke about the law of definite proportions. Okay, then we realized that the molecular weight of air is, what's the molecular weight of air? 28.94 grams per mole. And we have realized that the formulae can be very much used for calculation of air quantities. So what are the formulae that are used? amount of oxygen required is equal to 32 by 12 into C plus 8 into H minus O by 8 plus S kilocals, kilocals or calories. Okay. And the air that is required is given by 100 by 23 into 32 by 12 into C plus 8 into H minus O by 8 into 8 into H minus O by 8, and S is the formula that is used to calculate the amount of air required in kgs or grams by weight. Okay, so these are the formulae I am using. Okay, now we'll start doing our numericals. So good amount of time that we have done. Sare, problems numericals చేస్తే నేను ఏం ఎక్స్ప్లెయిన్ చేస్తున్నానో అది క్లియర్ గా అర్థమవుతుంది. సరే, టార్గెట్ ఏంటి? ఎంత ఆక్సిజన్ కావాలి కంప్లీట్ కంబస్షన్ ఆఫ్ ఫ్యూయల్ కి క్యాలిక్యులేట్ చేస్తాము. నెక్స్ట్ దానికి ఎంత ఎయిర్ సప్లై చేయాలో క్యాలిక్యులేట్ చేస్తాం. అదే టార్గెట్ ఆఫ్ టుడేస్ డిస్కషన్, ఎయిర్ క్వాంటిటీస్ ని కనుక్కోవడం. సరే, నేను ఏదో 4 ఫార్ములాలు రాసి రూల్స్ రాసాము, బట్ వి విల్ డూ ఇట్ in such a way that we understand the concept solving the numerical. Now take down the first numerical. Okay, calculate the weight and volume of air. Calculate the weight and volume of air required for combustion of 3 kgs of carbon. For combustion of 3 kgs of carbon. Calculate the amount of air required by weight and volume. Okay, for complete combustion of 3 kgs of carbon. Question, easiest question. Okay, again I'll go to the chemical equations. Carbon reacts with oxygen to form carbon dioxide. Equation is balanced. Okay, so 12 kgs of carbon, weight of carbon is 12 grams or 12 kgs. 12 kgs of carbon requires 32 kgs of oxygen. Therefore, 3 kgs of carbon requires how much amount of oxygen? 3 into 32 divided by 12. Enter. I too got one calculator today. What's the answer? 8. Hello, kids. Are you solving with me? 8 kgs of O2 is required, is needed. Okay. So for complete combustion of 3 kgs of for complete combustion of 3 kgs of board కనిపిస్తుందా సరిగ్గా? 3 kgs of carbon, I need 8 kgs of oxygen. Okay, so how much amount of air has to be supplied by weight and volume? This is by weight. Kgs kada, weight direct. So ఏం చెప్తాం? 100%. Okay, 100% contains 23% oxygen. So how much is required for 8 kgs? 100 into 8 divided by 23 kgs. Amount of air required is equal to 100 into 8 divided by 23. That is equal to 100 into 8 divided by 23 is equal to 34.78. That is equal to 34.78 kgs of air. Because it is kgs, it is weight. That's amount of air required by weight. Okay? Easy. Next. For volume calculation. For calculation of the amount of air required by volume. Okay, amount of air required by volume. How we are going to solve this? Huh? We know that 1 mole of air has how much weight? Molecular weight of air is 28.94 grams. Okay, 1 mole of air weighs how much weight? 28.94 grams. Okay. Now, understanding that, what we can say here? Okay. I know that for 3 kgs, for supplying 8 kgs of oxygen, I require how many kgs? 34.78 kgs of air. Okay. Now 34.78 kgs of air occupies how much volume? This will occupy 22.4 liters volume. Okay. So 28.94 grams will occupy 22.4 liters volume. Okay. If I want to convert into kgs into 10 power minus 3. Okay. Now tell me the answer. అర్థమవుతుందా? 34.78 kgs of air ఎంత వాల్యూమ్ అంటే ఇది మీ ఎక్స్ప్లెనేషన్ 1 mole of air weight ఎంత 28.94 grams or 28.94 into 10 power minus 3 kgs. ఓకే అంత అది ఎంత వాల్యూమ్ ఆక్యుపై చేస్తుంది 22.4 liters. ఓకే సో 28.94 into 10 power minus 3 kgs 22.4 liters space occupy చేస్తే 34.78 kgs ఎంత 34.78 into 22.4 by 28.9 into 10 power minus 3. This will come to 4.78 into 22.4 is equal divided by 28.94 is equal to 26.9 into the answer. What's the answer? That is around 26.9 meter cubes or liters of volume. Okay. ఇక్కడ కూడా ఇంటూ this and this gets cancelled. Okay, that's the answer. Did you understand? Did you understand this numerical? What? It's a mandatory question. You should understand this. Now, shall I dictate the next question? No, solve this question. You'll understand this. Solve this question. Calculate the amount of air required. Calculate the amount of air required for complete combustion of amount of air required by weight and volume. By weight and volume for complete combustion of. For complete combustion of. For complete combustion of 16 grams of methane. 16 kgs of methane. 16 kgs of methane. Calculate by weight and volume of air required for complete combustion of 16 kgs of methane. This is the second one. Combustion of 16 kgs of methane, CH4. Okay, that's the one. So what I should do? First I should write the chemical equation. Always you should first write the balanced chemical equation. Okay, what do you say? CH4 reacts with oxygen to form carbon dioxide, CO2 plus H2. That's the oxidation reaction. Now, is the equation balanced? Carbon, carbon, H4. So, 2 here. Okay. So, oxygen is 4. So, 2. That means, after writing this balanced equation, what I will come to the conclusion? 1 mole requires 2 mole. 1 mole requires 2 moles of oxygen. Okay. So, now what is the weight of this methane? 12 plus 4. 16 kgs of methane requires how many kgs of oxygen? O2 is 32 into 2. 32 into 2 is 64. So, 16 kgs of methane requires 64 kgs of oxygen. Fine? 64 kgs of oxygen. Okay? So, how much amount of air is required? So, 16 kgs will require 64 kgs. Direct substitution. So, what I write? Therefore, amount of oxygen required for combustion of 16 grams of 16 kgs of methane is equal to 64 kgs. That's the first one. Easy, understood. Now what I should do? I should do the calculations of air required for supplying 64 kgs of oxygen by weight and volume. Okay. So second one is amount of air required for supplying amount of air required for supplying 64 kgs of O2 is, I said 23%. Okay, so what I can do? 100 by 23 into 64. How? 100 kgs of air contains 23 kgs. Therefore, for 64 kgs of O2, how much amount of air? 100 into 64 divided by 23. That is equal to 100 into 64 divided by 23 kgs of air. Enter. 100 into 64 divided by 23 is 278.26 is 278.26 278.26 kgs of air has to be supplied for supplying 64 kgs of oxygen, because air contains only 23% of oxygen by weight. So to supply 64 kgs, I need to supply 278.26 kgs of air. Okay. So, got it. Now, this is all for your information. Okay. So, all right here, again it's easy. What I'll say? Amount of air required is, amount of air required is, give me the answer. 278.26 into 22.4 divided by 28.94. 278.26 into 22.4 divided by 28.94. That is 215.37. Meter cube or liters of air is equal. If I'm taking by volume, okay, it is 21%. That's the answer. Don't have any doubts, please raise your hand. These are compulsory questions, so I'm little I should say, keen that you should understand. By chance, if you don't, please raise your hand and ask. Okay? Your mid exams will pass very easily, but when it comes to your final exam, you will really bother yourself because compulsory questions. These are favorite for the examiners. Okay? Are you able to follow this? Okay? So these are the questions on one aspect. Now take down the next question. Calculate the weight of air required. Calculate the weight of air required. Calculate the weight of air required for complete combustion of. For complete combustion of. For complete combustion of 5 kg of coal. For complete combustion of 5 kg of coal containing 5 kg of coal containing carbon 80%, hydrogen 15%, carbon 80%, hydrogen 15%, rest is oxygen. Rest is oxygen. Okay. So this is the third numerical. What he said? Weight of air required. Weight of air. He is asking for weight of air required for complete combustion of 5 kg of coal. Okay. In the last numerical, the calculation was very easy because we only considered carbon present in the coal. Now he says the given sample has carbon 80%, okay, hydrogen 15%, the rest is oxygen. So oxygen will be 80 plus 15, that is 95. 100 minus 95 is oxygen will be 5%. Oxygen will be 5%. Now, the next step is which formula I have to use. For calculation of air quantities by weight, okay, we have the straight cut formula, okay. Amount of air required is equal to 100 by 23 into 32 by 12 into carbon plus 8 into H minus O by 8 plus sulfur. The units are kgs or grams. What you should always remember that here percentages are given. So have to convert that percentages into weight. Unlike the Dulong's formula gives the percentage of HCV or GCV. Okay. And the HCV formula also gives the percentage amount. But here, what you should identify here is that percentages are given, we should not directly substitute. Why? It is the amount that is considered. So, I'll first convert the percentage into weight. So, how much will be carbon? 100, 80% of 5 kg will be 5 into 80 by 100. that will be equal to 8 5s are 40. That is 4 kgs. That is 4 kgs. I am converting the percentage into weight. That's the first step. So amount of carbon will be equal to for 100 kgs 80. So for 5 kgs how much? 5 into 80 by 100. That is 4 kgs of carbon is present out of 5 kgs of food. Okay. For hydrogen, the calculation is simple again. 15 into 5 divided by 100. 15 5s are 75 divided by 100 will be equal to 0.75 kgs. Okay. The rest all is oxygen. Therefore, the amount of oxygen is 5 into 5 divided by 100. That will be equal to 0.25 kg. అర్థమైందా చెప్పింది? డ్యూలాన్స్ ఫార్ములా ఒకటే డైరెక్ట్ సబ్స్టిట్యూట్ చేయగలరు, ఎందుకంటే ఫార్ములా కూడా పర్సెంటేజ్ నే ఇస్తుంది. అదే మీరు ఎయిర్ క్వాంటిటీస్ ని కన్వర్ట్ చేస్తున్నారు అనుకోండి, ఏదైనా ఫార్ములా నేను ఇచ్చాను, అమౌంట్ ఆఫ్ ఎయిర్ ఆర్ ఆక్సిజన్ రిక్వైర్డ్ కి it is the weight that is considered. So when percentages are given, don't hop into writing the percentage into the formula. You should first convert that into weight. ఎవరైతే ఇవాళ క్లాస్ అటెండ్ అవ్వరో, by chance if the exams are offline, gone case, they'll directly put the percentage and they'll do the numerical wrong in a wrong way. Okay, now you can substitute very easily. Okay, so what's the formula for amount of oxygen required? Amount of air, straight away. Why oxygen? The question is air. So amount of air required is equal to, I'll get back to the formula, 100 by 23 into 32 by 12 into carbon. This is not in percentage, this is weight. Plus the formula is 8 into capital H minus O by 8 plus sulfur. Okay. And the whole answer is in kgs or grams. Now I'll keep it in kgs. Now can you substitute? Very easy. What? That will be equal to 100 by 23 into 32 by 12 into 4 plus this. If I take LCM, okay, it will be 8H minus O, and if I get it out, this gets cancelled. That will be 8H minus O. Okay, what is 8H? 8 into 0.75 8 into 0.75 minus 0.25. Sulfur is not there, so I will not consider. So the answer comes to 100 by 23 into 1s are 4, 3s are 12. Anything 32 divided by 3 is equal to 10.66. 10.66 plus, let me solve this, 8 into 0.75 is 6 minus 0.25. That will be how much? 0.75. This will be equal to 0.575. 5.75. Okay. So 10.66 plus 5.75 is equal to 100 divided 23 is equal to 71.34 kg. 71.34 kgs. That's the answer. That's the answer. Easy, very easy. I think for math students like you all, you can play with it. Okay. Now solve this numerical. ఏంటి అందరూ వెళ్ళిపోతున్నారండి చేసే ఏంటి న్యూమరికల్స్ చెత్త అని చెప్పి వెళ్ళిపోతున్నారా ఏంటి 10 మంది కూడలేరండి క్లాస్లో 18 people or 20 people are there. What's this? Okay, no problem. Okay. Now kids, solve this numerical. Calculate. It's an easier one. Calculate the minimum weight of air. Calculate the minimum weight of air required. Calculate the minimum weight of air required for complete combustion of 1 kg fuel. Weight of air required for complete combustion of 1 kg of fuel. Easy calculation. Okay, 1 kg of fuel containing carbon 90%, carbon 90%, hydrogen 3.5%, hydrogen 3.5%, oxygen 3%, and the rest is ash. Rest is ash. Okay. Answer the question. Calculate the minimum weight of air required for the complete combustion of 1 kg of fuel containing 90% carbon, 3.5% of hydrogen, 3% oxygen, and the rest is ash. Okay, do it. I'll give you 3 minutes, 3 to 4 minutes. Easy. Now the calculation is much more easy. If I convert that into weight, it will weigh. Carbon will be how many kgs or grams?